here today we are here to discuss about artificial intelligence and machine learning. So it is a training that is focused on operational people, so people working in the ops room or in an office next to the ops room or have an ops background and are involved in a machine learning or artificial intelligence a project. So the goal is to give you the minimum set of information, the minimum set of knowledge so that you can participate in an AI project, know your place, know what is expected from you, and maybe deliver more that what is expected. Voilà. So let's start. Clack. Up. Voilà. So the objectives of the training are to explain to you the basic of AI. What is an AI product? What is different from conventional software? Explain to you what is AI good at? Because there are a lot of myths, a lot of things around AI that it can do everything that it can do, papa and mama, as we say in French. But that's not completely the case. It's dedicated to certain aspects to find certain things. So there we will come on that and explain that to you. Show a simple AI example. Very, very basics example. It's an exercise for learning AI. So you will see it's very simple, but it holds the basic concept of AI. Explain the development process of AI. So it is different than conventional software. So it has its own development process. So you will go through different steps than the one you do for conventional software. So there we will explain that to you. And then Camille will explain to you a real project, so hands-on, really a project that we had in Eurocontrol in NM for NMOC. It's an airline route predictors, and she will explain to you how the software was developed, how the journey, what was the steps and the path that we took to produce that piece of software. Voilà. All good. I'm just checking that everything's good. We are 34. I'll just look in the chat that everyone's there. Up. Okay. Well, all good. There is a bit of a problem with Camille, but we will check that just after when I hand the hand to her. Up. Let's go. Let's dive into the topic. So what is AI? So as we are engineers, we love complex definitions. So let's go through this definition and let's see what it is. So I will explain to you and make it simple because here it is a bit complex, a bit complicated. AI systems are software and possibly also hardware systems designed by humans that, given a complex goal, act in the physical or digital dimension by perceiving their environment through data acquisition. Let's stop right here and let's go again over what it is. So AI systems are software. Okay, basically algorithm, things that runs on a machine, simple. Possibly hardware. So here you have to think of robots. An AI placed in a robot and a robot acting like in a factory, transporting pieces or packets from here to there, etc. It is designed by humans, so it is very important this because AI are based on a business problem, something that you have today, things that you want to do, tasks, automation, things that you want to do today and that you would like to have done by a software. Given a complex goal, so that relies with your business problem, what you want to do with the software. So the software, you have your problem, and the goal is what you want to do. Act in the physical or the digital dimension. Physical, that will be a robot that will do things in our environment, or an autonomous car that will drive on the road. And digital dimension, it runs on a server somewhere and provide the results to you. That by perceive their own environment through data acquisition. So here it is very important. So if you think of this autonomous car, she will discover a red light here, a pedestrian there, a truck there. So there it's a data perceive their environment through data acquisition with sensors. And for our systems, the algorithms that we run in Eurocontrol, for instance, it's flight information, all the events that happen for a flight. It can be environment data. It can be flow data. So here we will gather or grab this information that we already store, for instance, in the data warehouse on or our servers in Eurocontrol, and inject in the machine. Interpreting the collected structured and unstructured data and reasoning on the knowledge. So there it is more of the data crunching and the data analysis. So you have your problem, you have your goal, so what you want to solve, and you gather data and you inject the data in the system. And that's what is meant here. Or processing the information derived from this data and deciding for the best actions. So basically you have your problems, your business problem, you have your goal, you inject the data in the model, you train the model so it does what you want to do, it's the goal that you have, and then based on the data, based on the model that has been built on the data, it decides the best action, basically it serves the goal. So these very, very complex definitions means that you have a business problem, you have a goal, you have a set of data, you will create the model, the AI model. So the AI module is actually the algorithms, the software that will execute the goal, and then you get the results. So that's the very complex definition. So this is what is meant here. Moving on. So in the past, you must have done already machine learning. So machine learning is actually a subgroup of AI. So there are AI that do not need data, but for us, we use only machine learning, and we will focus in this training on machine learning. So if you remember, whenever you had a generator and then you want to check the voltage and the intensity from that generator, at school you must have constructed these graphs. And what the AI model does is when you draw the line, so you measure the voltage and the intensity, you plot on a graph, and then you draw the line and you say, okay, if you have a voltage like this, you will have an intensity like that. Wherever you have no measurement, so wherever there is no blue dot on the yellow line, then you can know what is the voltage or what is the intensity. Well, it is all about fitting a model on a data set. So the data set is the data we talked about. So you have a set of data. Here it is measurements of voltage, of intensity, but it can be flight data, it can be flow data, it can be environment data, etc. And what you just do is that you just do something more complex. Voila. So this is what we do. So it is getting the data and derive statistical information, derive predictions of it. So this webinar details only machine learning, as I explained. It is a subgroup of AI. You have AI that do not need data. You have AI that do not need training, etc. Do not need machine learning techniques. But so far, and we observe also in the field that the most popular techniques are AI, are machine learning techniques. So we'll focus on machine learning today. And if you want more information on other part of AI, then you just contact either me or Camille, and we will be very happy to answer. A bit of history. So AI is something that is not new. There have been research in AI since the early 40s, and all over the second half of the 20th century, there have been theory, or there have been research and discoveries on machine learning, on AI, etc. So the question is, why now? Why it started in the 40s and just today it became trendy? Today we see AI all over the place. What changed? What triggered this possibility for AI to materialize, let's call it business value, let's call it goods, let's call it delivery? What is possible today that was not possible yesterday, although people, very bright minds, were working on that and making very useful discoveries? Well, it is two things. First, the computing power. So today we have an unprecedented computing power. Computers have not been so powerful ever. So today we have a lot of machines, we have a lot of servers that are able to crunch the data, that are able to run the algorithms that were discovered in the second half of the 20th century, but we were missing the computing power, we were missing the muscles or the brains to actually perform the operation, and also the amount of data. So with the development of the web and the connected devices like smartphones, sensors on the streets, etc., there have never been so much data around. So we have the amount of data to feed AI algorithms, and we have the computing power. So these two things, the happening of the computing power and the possibility that we have with the data, makes that it is possible today. Just a short, une petite aparté. Here, the Fly AI report. So you may think that still AI is the future. AI is something that is science fiction. It will happen in a few times. Let's say in 2 years or 3 years, you will have it in an NM release, or you will see it happening in ATC. Well, it is not completely true. The Eurocontrol has developed the Fly AI report that has been published at the beginning of the year. And in this graph, you see exploration, research and development and deployment projects. So you see that there are many projects using AI, using machine learning algorithms that are close to deployment. So have a look at the Fly AI report that is available on Eurocontrol website. If you don't have it, I can send you the link. And just read maybe the executive summary and you will see that first, AI is happening, and second, we are very close from having it in operation. There are already at Maastricht, for instance, systems based on AI running close to the ops room. So now let's see what AI is good at. So we've seen that AI is a system that's based on the business problem, will serve a goal and will learn of data to serve that goal. But what actually we meant? When can we use data? When can we use AI system? So basically, we can use it for 3 things. So clean the earth after an apocalypse, kill everybody, or just browse the space, smoking cigars and drinking beers. So this is really the demystification. So this is really the bad jokes. I love bad jokes. To explain to you that there is a lot of myth around the AI, but actually AI is good at only 4 things, and I will come to that. So we see a lot of science fiction, a lot of fantasy around AI. So you just throw AI in the pot and then magically everything's fine. Well, that's not completely the case. AI, as I said, is good at 3 things. For real. So I'm making groups. So whenever you have a set of data and you want to put this data into categories, think of a spam filter, think of a yo-yo flights predictor, think of military aircrafts, so recognition over image, etc. So you will say, here are the categories that I want to fit data in. And you will create a system that will classify these informations into categories. So classification is known categories, where clusters is unknown categories. So unknown categories is something a bit abstract, but let's think of a set of trajectories between Paris and Istanbul. So you will have flights that will go over Germany, some over Swiss, others over Italy, and you do not say to the system which category you want. You want to create a group of consistent trajectory. So you will say, I want 6 consistent group of trajectory. You will send the trajectory to the system, and the system will tell you this trajectory belongs to that group, and will put them in 6 groups. So with that, you will maybe be able to discover things that you don't know. You will discover categories that you didn't suspect or envisage at the beginning. So classification, known categories, clusters is consistent group based on statistic analysis. So not known categories, you don't know. You want the system to tell you which categories are similar to which data is similar to another. Predict, so do prediction. like number of open sectors in an airspace, like takeoff time predictions. So here really observed in the past, learn on past data and predict an event that is known in the past, that happened in the past, in the future, like a takeoff time, like a delay, like the number of open sectors for a given day, etc. So you have numbers like time, like I said, like a number of open sectors, but you have also probabilities like trajectories or predict trajectories or routes. What is the most likely route that an aircraft will fly between two airports? So this is the predict. So it is something that will estimate in the future something based on something that happens in the past. Draw relations. So here we have association, link, and data reduction. Association, it's like when you browse Amazon and it proposes to you other products that you are likely to like. So association, when someone will tell you we can do association with AI, think of this. So it is link things in an ensemble in a amount of data. Link is more the friends recommendation or the video on Netflix. So you have seen that, or you have that friends, you have this friend, so you are likely to like that video or that person. Data reduction is very interesting. It is when you have a huge amount of data, it will help you to keep only the relevant ones. So imagine that you have a problem where you have thousands of fields and columns and etc. Let's think of a huge Excel spreadsheet, and then data reduction will weight the fields, tell you the ones that are important, the columns that are important, and only keep you a set of manageable amount of data. So it is very interesting when you have too much data actually. Discover, so reinforced learning. So it is a continuous learning. Let's think of an autonomous car. You put it on the road, and then the car will continue to discover, here the traffic light, here pedestrian can come from the right, come from the left, here is a truck, etc. All the situation that the car will encounter will be stored, learn, so the car will deduct its behavior. It has to turn right, to do an escape move, etc., etc. So discover, it is really our robots in a factory that do not know the factory, that has not the plan, but will discover that here is a wall, so he can't pass through, of course, and then move to other places. Voila. So here is that was what AI is good at, and here is a set of techniques. So we won't go over all the techniques here. It's just for you to have them. If you want to know more about all the techniques of machine learning, you can go to that YouTube video that will go over in more detail. So I will go just on the three major categories. The unsupervised learning is when you just throw the data at the AI and the AI produce results, a bit like the clustering I was mentioning to you. You don't know what are the categories that you want to have. You don't know yet how to group in an efficient manner your data. So you just give the data to the system, and the system, based on statistical reasoning, will tell you, okay, this data belongs to that group, or that group. Supervised learning, you just tell the system what are your categories. You tell your system what you want to predict, and it will give you. Reinforced learning is online learning, so the system will continuously learn and continuously reinforce or improve its behavior. Important to know, you have two types of learning. Online learning, so you continuously learn and you have no distinction between the training of the AI and the run. So each data that comes through the algorithm is subject to learning. So the behavior of the system will change over time. And offline training, it's very more important for us because we want to have possibly a deterministic approach. So for a given input, we want to have always the same results. So here, offline learning will be you learn for a while, you put in operation. So let's say that you have a system that you put in the ops room. You take it, you put in the ops room, and you want the system to behave always like it behaved on the test bench. So this is the goal of the offline training. So you train once and then you run, where the online training, all data that arrives to the AI will be learned, and then the behavior change. Very, 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 very important. Machine learning is about data, and that's why I put 3 times data. So like all, for those who see data fundamental value and learn to extract and use it, there will be a huge reward. So the goal and the challenge of AI project lies in understanding the data. So that's the bit of the goal of the cartoon. You see data is like these spots. So there you have a lake or a huge amount of data, and you start digging. So you start looking for information. So each individual data has a separate meaning. And the knowledge part is when you connect the dots. Insight is when you can deduct things from the information. Wisdom is when you make the connection between the dots. So it's really that the goal of an AI project is to connect the dots between separate data, between large amount of data, etc. And the goal of conspiracy theory is to see unicorns everywhere, but that's the subject of another training. Up. So looking at a concrete example. So we've seen that AI is good at certain things and it relies on data. But once you have this data, how do you process them? What is the machinery, or what is the role of data that we haven't touched yet, and we will go over it just now. So let's look at the business project, the business problem. So the business problem is to find what feature make the price of a house. So we have a set of information. We have 13 fields of very relevant data, or what we believe to be very relevant data, that will make the price for a house in a certain neighborhood. So the crime rate, the access to motorway, the age of the property, the number of rooms. So we have 13 fields, and the goal is to create an AI model that will predict the price based on this. So when starting looking at the data, so you will investigate the data, and you will find that there are some that have no correlation at all. So some can be very high, and yet the price of the house will be very low, can be very low, and yet the price of the apartment will be very high. So you see here the green dots do not match with the yellow line. So it means that there is no correlation. Here they match a bit. So we see that there is a trend here a bit, but not quite. And here also, we see that there is a trend, but not that much. So moderate correlation. So this data have only a marginal effect on the price. But here we see, it has big impact. We see strong correlation. So here, RM is the room number. So you see that the more room in the apartment, the higher the price. And let's see what LStat was. Up. LStat was the poverty rate of the area. So you see that if you are surrounded by rich people, then the price of the apartment is higher, because when you are in an area when there is more poverty, then the price is lower. So it makes sense. So you see that there are 3 types of data. Data that have no role on the price, that even if they are in our database, they don't play a role on the price. Here, moderate, so it is the one that you may decide to include or not on the model. And these ones are really the ones that you want to crush and to build your model on. So that's the main occupation. The main occupation is understand the data, see the ones that are relevant for the business problem, and then construct the model. So that leads us to what are the steps to create an AI model? How do you do you create? I already mentioned it a bit. You will see. Since the beginning, I'm talking about a business problem and then data, etc. So here it is in a slide, and here you see what are the different steps. So problem definition, very important, essential keys. If it is not done, then you're in trouble, or if it is poorly done, then you're in trouble. Define precisely the problem we want to solve. So really define what you want, what is the goal, what is the things that you want to do. Let's say a classification for yo-yo flight. So you have a set of flight, a set of trajectories, and you want to detect what are the ones that are yo-yo flight, what are the ones that are not, or a prediction of a takeoff time. This is the type of problems that you want that you may want to analyze, to work on. Then data analysis, very important, as machine learning is based on data. So you will study the relevance of your data, the field, the interactions. For the takeoff time, you may want to take into account the delay of the previous leg of the aircraft body, or the arrival at the time of arrival at the airport before the turnaround starts, etc. For yo-yo flight, you want to maybe to look at the vertical profile of the trajectory, etc. So really study the relevance of data and what are the interaction, what are the fields that you have, etc. Then data transformation, clean the data. So data comes as they are recorded. Sometimes they have outliers, so measurements or value that are completely off the charts, incoherent data, holes in the data, etc. Data augmentation is when you have too few data and you want to increase the amount of data. Think of a classificator between cats and dogs, for instance, and you have too few image of cats. Then you will maybe turn the image, or you will process the image in a different way, maybe change a bit the image so that you can do. Data augmentation is not something for us. We have a lot of data. So really think of cleaning the data, removing the outlier, things that are off the charts, incoherent data, holes, etc. Feature selection is the insights that we found and the connection between the insights that we found, that we've seen on the cartoon. So it is select the relevant fields. It is the room number or the poverty rate of the previous exercise. So it is really select the features that are key decisions factor. So data fields that play a role in the solving of your business problem. What are the data that makes a flight a yo-yo flight? What are the data that helps to predict a takeoff time? Model selection, so it's which machine learning algorithms you will use to create the model. Then you have clean data, you have your algorithm, you train the model, so minimize error of model with respect to training sets. So it's a bit complex, but it's really pass the data through the model, through the algorithm that you selected at the steps before. And model testing, of course, once you have a model, you want to test it, you want to see if it works. So there is just a testing. You have it. Let's test it. Let's see what are the predictions that it makes and if it's good. The very important to remember, the processing of the data takes the most of time. So 80% of the time of the project will be spent on this part, and only 20% of the project will be spent on the model training, testing, and model selection. So really, the huge part of the work is done on the data analysis, data transformation, feature selection, and also whenever you have results, you may want to go back. So let's say that the model selection, something is strange and you want to change the model, then you may have to transform the data again, change the feature, the relevant data. And also at the testing, if you found poor results, then you may want to come back, etc. Where is your role? So whether you are an ops staff or a project manager, where do you play a role? What are the steps in this process, in the journey to make AI system that you will be involved of? in. So let's see for operational staff. So very impersonal staff play a key role in the problem definition. Basically, you say what you want, and the engineers will work at providing what you want. Very simplistic approach, but it should work like this. Only an ops can say what is the problem and what is the feature, what is the goal, what is the service that the AI model needs to run. Data analysis, this is where ops people need to transfer the knowledge on what is the data, what is a takeoff time, what is a yo-yo flight, what is a route, what it is made of, what are the basics data that makes a field 15, etc. So this is where you transfer the knowledge to engineers, to data scientists. Data scientists are the people that work on the data crunching and the AI model. So it is very important that those guys, those ladies understand what are the data, what is the business role or the business value of this data, and then can work. So for instance, when they get the results out of a model or out of a data transformation, that they can see, no, that's too strange, that doesn't make any sense. We have to do it again because the ops lady told us that the data should be between 0 and 10. We get 34. Okay, that's completely crazy. Then the project will work, you will be involved, but a bit less, and you will have real value on the testing. So to evaluate what is the results of the work, what is basically the value that the system gives. In between data transformation, feature selection, model training, you will be there, but you have less of an important role. You will be involved to avoid the tunnel effect, etc., so that the project drifts, actually. But your key role is to problem definition, transmit, or send the knowledge contained in the data to the team so they can work. For project manager, it is very important that you support the ops people in their problem definitions, in the data analysis also, that you make sure that the data scientists have understood what is explained by the ops people. In feature selection, you will have to challenge based on the knowledge that you gather at data analysis, your data scientist to make sure, are you sure that you use the right feature? Remember, at data analysis time, we talked about that data. Can you prove it to me that as you didn't include it in the model, that it is not relevant? Model selection, also you will have to challenge them on why did you choose this algorithm? So why not this one, etc. So that you are sure that the data scientists provide you with the best algorithm. And of course, at testing, you will have also to test before it is transmitted to the ops people, so that you catch the biggest mistake. Voilà.